4.5 day 1 was all about solving exponential equations. 4.5 day 2 is about solving logarithmic equations. So something that you saw on 4.5 day 1 was to undo an exponent, we took the log of each side. Now, if we're using a logarithm, one of the methods will be to take an exponent of each side. Let's start off with an easier method though. This is going to be method 1. It's really nice if I give you something where the logs have the same base on each side. Because if the logarithms have the base on each side, all we have to do is set what's in the first logarithm equal to what's in the second. So when I take a look at example 1, I have log base 3 of 5x minus 1 equals log base 3 of x plus 7. So because I have the same logarithm, I can go ahead and just set 5x minus 1 equal to x plus 7 and solve like I normally would. So I need to try and get x by itself. Let's go ahead and move this x over here. That gives me 4x minus 1 equals 7. I need to move this negative 1 over, so plus 1 plus 1. That gives me 4x equals 8. Still isn't by itself. I need to divide each side by 4. That gives me x equals 2. Remember, we need to check for what's called extraneous solutions. So I just need to plug it back into my original equation, make sure I get the correct answer. So 5 times 2 minus 1 equals log base 3 of 2 plus 7. So essentially what happens here is we want to make sure we get the same thing on each side of the equation, remember? So what I have over here is log base 3 of 5 times 2 is 10, so 10 minus 1 is 9, equals log base 3 of 2 plus 7, and 2 plus 7 is 9. So you can see I have the same thing on each side of the equation, so yes, it does work. If you wanted to go one step further, you could evaluate the logarithms. We know 3 squared would give me 9. So it really is 2 equals 2. Let's take a look at method 2. So method 2 is what we use when it's not nice, where we have the same log on each side. So when that doesn't happen, you exponentiate each side. So remember how I mentioned before in day 1, we had to take the log with the same base of each side. Now we have a log and we're going to exponentiate each side. And what that means is what's on each side of the equation becomes a power. And the base of the exponent needs to be the base of the logarithm. So the base here was 3, so I have 3 as my base on each side. It's kind of hard to see what this looks like without me rewriting it, so I'll go ahead and do that. It's 3 to the power of log base 3 of x minus 5 equals 3 to the power of 2, so 3 squared. At this point, what we have here is the inverse property. So they actually cancel each other out. That's why I used the same number as the base. I did that intentionally. So I'm just left with x minus 5 equals 3 squared, which is 9. And I solve for x like I normally do. So I'd add 5 to each side. That gives me x equals 14. We do need to check and make sure that it does in fact work out. So I'm just going to plug it back in wherever I see x in the original equation. 3 as my base, I have 14 minus 5, which is 9. I need to show that what's on this side of the equation is equal to this side. So 3 to what power would give me 9? The answer is 2. So 2 does equal 2. It works. Example 3. Once again, I need to exponentiate each side. So I have a log base 5 here, which means when I exponentiate, the base needs to be 5. Meaning I have 5 to the power of log base 5 of 3x plus 1 equals 5 squared. The log base 5 and the 5 cancel out. So I have 3x plus 1 equals 5 squared, which is 25. I solve for x like I normally do. You must subtract the 1 first. So I have 3x equals 24. And then you divide by 3. So x equals 8. I need to check and make sure that it really does work. So I'm going to plug that back in. Log base 5 of 3 times 8 plus 1 equals 2. 3 times 8 is 24 plus 1 is 25. So I have log base 5 of 25 equals 2. Let's evaluate this logarithm. 5 to what power would give me 25? That's 2. If you ever are confused about the circle trick, you could also, it's worth mentioning, you could use the change of base formula here. Log of 25 divided by log of 5 is 2. So I have 2 equals 2. So you have options. It did check, so 8 really is a solution. Example 4. I cannot take the logarithm, or excuse me, I cannot exponentiate each side yet. So something I haven't mentioned before, because it hasn't come up, is that when you exponentiate each side, you can only have one logarithm. I have 2 here. So what we're going to have to do is condense using our properties of logarithms. If this were addition, I would use the product property, which is where I multiply these two together. However, this is subtraction, which means I need to divide 4x by 3. So I have log of 45x over 3 equals 1. So again, I've condensed the left side of the equation using the quotient property. Now that I have one logarithm, I can exponentiate each side. And remember, the base of the exponent needs to be the same as the base of the logarithm. There is no base explicitly listed here. So it's understood to be the common logarithm. And a common logarithm has a base of 10. So I have 10 to the log of 45x over 3 equals 10 to the first power. The 10 and the log cancel out, so I just have 45x over 3 equals 10 to the first power, which is just 10. And I need to solve for x like I normally would. There's different ways you could do this. You could multiply each side by 3 and then divide each side by 45. Or I do see 45 divided by 3. That's just 15, isn't it? So I could do 15x equals 10. And now I'm going to divide each side by 15. So x equals 10/15. This is not an appropriate answer because it's not simplified. Both of these numbers are divisible by 5. So really, x is 2/3. let's make sure that this really does work. I have log of 45 times 2/3 minus log of 3 equals 1. 45 times 2/3, if you want to plug that in your calculator, you can. 45 times, I just want to remind you, to do a fraction, you need to use parentheses. So 2 divided by 3, you get 30. Another way you could have done it is just simplified it. So I see 45 over 3. 45 divided by 3 is 15. 15 times 2 is 30. Minus log of 3 equals 1. I'm trying to prove that's what on this side is equivalent to this. So I can condense it by dividing, since it's subtraction. Log of 30 divided by 3. 30 divided by 3 is 10. We do have that rule that says any log base b of b will give us 1. Because if you ask yourself 10 to what power would give you 10, the answer is 1. So it does check. 2/3 is a solution. That one was a tricky one. Let's take a look at example 5. It's pretty similar. The first thing we have to do is condense because we need just one logarithm. So I have log base 4 of 100 divided by x plus 1 equals 1. Now, I have a log base 4. In order to undo it, I need to exponentiate each side using the same base, which is 4. So this is gone, and I just have 10 to the x plus 1 equals 4 to the first power, or just 4. When you're solving for x, you need to get it out of the denominator. So what I would do is multiply it by each side. That gives me 10 equals 4x plus 4. Make sure you distribute it to each term. And then subtract 4. 6 equals 4x. And then, oops, I just realized this was supposed to be 100. Sorry, so that's a 96. Divide by 4. 96 divided by 4 should be 24. Sorry about that. All right, I need to check and make sure it really does work. So I have log base 4 of 100 minus log base 4 of 24 plus 1. 24 plus 1 is 25, so it's log base 4 of 100 minus log base 4 of 25. We could use quotient property here. When we condense it, we get log base 4 of 100 over 25. 100 divided by 25 is 4. Same thing, log base b of b is 1, so log base 4 of 4 is 1. It does work. Or you could use circle trick, 4 to the first power gives us 4. It works. So it is a solution.